Hello, let's continue to solve topological sort problem. This is going to be 210 course schedule 2. So the only difference is that for course schedule 1, we want to check if we can finish all courses, but for course schedule 2, we are going to get a topological structure. It's going to be an array. And we should know that if there is a topological sort, if we call it a topological sort, basically we call it is a topological structure. So if it is a topological structure, for example 0, 1, 2, how can we get a topological array? So basically we can have a 0 but we cannot have 2. We have to finish this course 1 because 2 is dependent on 0 and 1. So it's going to be 0, 1, 2. So this is a possible result. Another result is we can finish course 1 and then we're going to finish course 0 and then we're going to finish course 2. Yeah, but we can never finish the course 2 first. So this means we have 2 topological structure. So this is why we're going to return the ordering of courses you should take to finish all courses. If there are many valid answers, we just need to return any of them. If we were to return all of them, definitely it's going to be difficult. But this problem is easy because we just need to return any of them. This means we can use the Kahn's algorithm directly. So if you know about, I don't know how to spell it. Yeah. So it is called Kahn's algorithm. Yeah. You can use Kahn's algorithm directly to solve the problem because Kahn's algorithm definitely we can find a sequence. It is an array, and it is totally the same as course schedule 1. We just needed to change a little bit. Yeah. Now let's try to solve the problem by using BFS. So as I always did for a topological sort problem, I'm going to prepare a graph and integrate. So the graph going to be a default dict, and inside I'm going to prepare a list. So this is going to be an adjacency list, and for the integrate I'm going to prepare 0 times the number of courses from the beginning. Now I'm going to prepare the graph and integrate. So for AB in the prerequisites, so for the graph, as we know that if we were to finish course A, we have to finish course B first. So this means we're going to use course B. Graph with course B should append with course A because there is a dependency for the graph, and this is a directed graph. And also for the integrate, because for the integrate we want to finish course B first and then finish course A. So this means A is dependent on B. So this means for course A there's going to be integrate plus 1. Yeah. Now we're going to prepare the result and Q. Let me write it as Q and result. So Q going to be at the Q, and inside it's going to be all the nodes which have an integrate of 0. So it's going to be I. So for I we enumerate with the integrate So if the number of the integrate, if the integrate equal to 0, definitely I want to put all the nodes inside the queue, and then I'm going to prepare a result array because finally I'm going to return this result array. Yeah. Now let's just try to finish the BFS part. So while q, I'm going to pop the node, so it's going to be the q.pop left, and then I'm going to check the neighbors. So for neighbor inside the graph for this node. And then I'm going to check the integrate. So for the integrate with this neighbor, going to be -1. And then I'm going to check the integrate. If the integrate with this neighbor equal to 0, definitely I want to put it inside the queue. So I'm going to append the neighbor inside this queue. Yeah, but currently we didn't put anything inside the result array. We can put it easily. We just need to put the node inside the result array. Yeah, but we are not sure if we can put all the nodes inside the result array. This means we need to have a check. So if the length of the result equal to the number of courses, it means everything is okay. Otherwise, if we didn't pop all the courses, we just needed to return an empty array. Yeah, because if it is not possible, we just need to return an empty array as it is set from here. Now, I think that everything should be okay. Let me run it to tag. As you can see, it works. Now let me submit it to tag if it can pass. As you can see, it passed all testing cases. And the time complexity is m plus n. M is the number of vertices and n is the number of edges, or vice versa. Yeah, it is just OE plus V, number of edges plus the number of vertices. Yeah. Thank you for watching. See you next time.